In this video, the goal is to summarize what you learned in chapters 3 and 4 and also give you a little bit more practice with some of the big ideas. So in terms of what we know so far, based on what you've studied in both chapters 3 and 4 and chapters 1 and 2, we know there are different ways to obtain samples. We know that ideally what we want is a sample that is representative of the population of interest. We know that a random sample will give us a representative sample, but certainly we might be in situations where we cannot sample randomly, and we can still be fairly confident that we're getting a representative sample. So we always want to look very carefully at our sample and think about who the population of interest is, and think very carefully about whether that sample is going to be a good representation of that population. We know that if the sample is not representative, then we need to be cautious in terms of the inferences we draw about the population or the conclusions we're drawing about the population. So unfortunately, there are times when we're just not going to be able to get a representative sample, and that's not a terrible thing. It's not ideal, but you can still certainly draw some conclusions, but you just have to be, again, very cautious. You have to let your audience know that there could be problems with the sample, and the sample might not exactly represent the population in the way that we would want it to. So another thing that you've learned about is just this idea that sample size is really what's important. So it's not the size of the population that matters, but it's how big of a sample you can obtain. So we really want to focus on this idea of obtaining a good sample that'll help us decrease the margin of error, that'll help us, again, in terms of trying to make the best possible inference or conclusion about what's going on in the population. And just naturally, intuitively, bigger samples are better, but we can't give you this number right now and say this is exactly how big of a sample you need. So we just want you to think very generally about this idea that as we get a bigger sample, we know our margin of error is going to decrease, and that's a good thing. So we really want to concentrate on the size of the sample and not be worried about how big the population is. So think back to that soup analogy about having a bigger kettle of soup and whether you would need a bigger spoon in order to get a good representation of the taste of that soup. So another way to think about the important ideas, just think of a diagram like this. So the big idea in statistics is that we are very interested in knowing about a population, about lots of individuals. We attempt to randomly sample or randomly select from that population. We then have a sample, which is a subset of the population, and from that sample we can draw inferences or draw conclusions back to the population. So understanding these terms of population and sample, understanding what those things mean, that will be very important. Understanding that the big thing that we do is we're interested in a population. We often can't gain access to that entire population, so we have to take a sample from that population and then draw our best conclusion back to the original population. Another thing to think about is just this idea of the difference between statistics and parameters. So we've talked about that, and we've had an example of that. So remember that the population starts with a P, a parameter starts with a P. We want to describe a population from a parameter. So the mean of a population, the population proportion, the population standard deviation. So you'll soon learn about what the standard deviation is. When you're describing some characteristic of the population, whether it be the average of the population or the variability of the population, you have a parameter. And then when you have a sample and you want to describe something like the sample average or the variability of the sample, we compute what's called a statistic. And so we have SS and then PP. So we hope that that'll help you remember the difference, help you remember what a parameter is for, and help you remember what a statistic is for. Okay, so something else to think about. Another really big important idea in statistics. So I want you to imagine for a moment that, let's say that we're in a large lecture hall at OSU, and maybe unknown to us, if we were to average the ages of all the students in the lecture hall, the average age would be 22 years. And so let's just imagine we're thinking of that lecture hall as a population. So all the students in there comprise the population. Their average age is 22 years. And so if we're using that average to describe the population, we know we would have a parameter. Now, let's say that I take a random sample of 10 students and I find the mean age of that sample. So I would have a statistic. Now let's imagine that you do the same thing. You also take a random sample of 10 students and you obtain a sample mean, so you obtain a statistic as well. Do you think that you would obtain the same mean that I did? So think about that for a moment. I'm hoping what you're thinking is no. You're thinking that we're both sampling randomly. So because of that, it's very possible that we're going to have different students in our samples. We're not going to have the exact same samples. Certainly it's possible that we could obtain the exact same average, but what I want you to be thinking about here is the fact that from sample to sample, we're going to have some variability. So if every single one of you in Stat 1350 did this, you all went to this lecture hall, you all took a sample of size 10, a random sample of size 10, we would have sample means that are different from each other. They're not all going to be the same. There's going to be some variability in those sample means. So sampling variability, the idea of what we would expect to see from sample to sample. If we randomly select individuals to be in our sample, what do we expect to see from sample to sample? We expect to see variability. And this idea is really important in statistics. We're trying to capture sampling variability. We're trying to understand sampling variability. We take that into account when we take a sample of data and try to make an inference back to the original population. We always have to be thinking about the fact that samples vary. And that's what we think about when we actually compute a margin of error. We're trying to take into account variability that we would naturally expect to see if we could repeatedly sample from the population. And here is just a quick visual of what I'm talking about. So here again, imagine that this is our population. We have lots of individuals in our population. And I decide I'm going to take a random selection of those individuals. I get this set of individuals for my random sample. Perhaps then you decide you're going to take a sample and you get a different subset of individuals. So you're just randomly taking individuals from this population. Another student comes and decides to take a sample. Another student comes and decides to take another sample. So hopefully you're getting the idea here. We have variability from sample to sample. If we kept doing this over and over and over again, just taking lots and lots of samples, we're going to see lots and lots of differences. And if we then compute a statistic from the sample, the statistics are not all going to be the same. There's going to be difference from statistic to statistic. So again, that's what we're taking into account when we compute a margin of error. When we have one single sample from a survey and we compute a margin of error, we have to be thinking about how could our sample be different from another sample we could have easily randomly drawn. And if we're going to take our sample and make an inference back to the population, we need to think about the fact that our sample is just one subset of lots of possible samples we could have drawn from the population. So we have to be thinking about the variability, this idea of sampling variability. So again, more on the margin of error. One thing I really want to emphasize to you is this idea of sampling error. So you learned about that in chapter 4. So remember what a sampling error is. A sampling error has to do with the method that you're using to take your sample. So errors that can occur in the act of actually taking a sample that will cause your results to be different from the results of a census. So remember, one possible sampling error could be undercoverage, that you've left out this big chunk of the population in your sample. You haven't done the best job of trying to take the best sample. You're using a voluntary response sample. That's a sampling error where you're not trying to sample randomly. Now, as chapter 4 mentions, and it's mentioned maybe somewhat briefly in that chapter, but it's a very important idea. I want you to pay very careful attention to it. It comes up right toward the beginning of chapter 4, that when we're determining a margin of error, the only kind of sampling error that is involved in or included in determining the margin of error is what is called random sampling error. So the margin of error only takes into account random sampling error. That's a very big, important idea. Write that down. The margin of error only takes into account random sampling error. It doesn't take into account other sampling errors. It definitely does not take into account non-sampling errors. It only takes into account random sampling error. And what is random sampling error? That's the deviation between the sample statistic and the population parameter caused by chance in selecting a random sample. So if you think back to the previous slide, that would be our idea of sampling variability, that just by chance, as we're sampling randomly, we're going to see differences from sample to sample because each sample is going to be comprised of different individuals because of what we did, because of that act of randomly selecting from the population. So when you're thinking about the margin of error, you have to keep in mind that it only includes this idea of sampling variability. It only includes random sampling error. Now, again, I know this idea of margin of error is confusing. It tends to be one of the more challenging ideas, and you're learning about it now in chapter 3. We're going to come back to this much later in the semester when we start talking more specifically and more in detail about confidence intervals. But lots of times, again, when you see a poll result published, they will share a margin of error. A margin of error helps us understand how close our estimate, and our estimate would be the information we're gaining from our sample, how close that comes to the truth. So just very formally, this is from your textbook, the margin of error takes into account the fact that there's going to be variability from sample to sample based on what happens when random samples are chosen from a population. So again, the margin of error takes into account random sampling error. It takes into account sampling variability. That's all it takes into account. And again, as we've already talked about, many published poll results will report a margin of error based on a 95% confidence level. So we'll come back to that idea later. We'll describe in more detail what we mean by 95% confidence. Why do we settle on 95% confidence? Can we be confident at other levels? The answer is yes. So as a researcher, you have some decisions to make in terms of what level of confidence you want to have, and that's going to affect what your margin of error ends up being. So you'll see that later on this semester. And just to translate this idea of margin of error, we used a sampling method. So margin of error relates to this idea of what's happening during our sampling method. We're using a sampling method that gives us a result this close to the truth 95% of the time. So whatever your margin of error is, that's how close you are to the truth. And we're going to go through an example in a moment, a couple of examples where we can practice this idea. And again, the level of confidence is varied by the researcher. So most times it's at 95%, and we're hoping as you get more through the course, you'll have an understanding of why we settle on 95%, why we would set things at 95%. But again, later on this semester, after the midterm exam, toward the end of the semester, we'll talk more specifically about the ideas of level of confidence. So more statistics in the news. Let's talk about a study. I thought this was kind of an interesting study. College students will literally text through anything. And I actually might talk about this study in another video. I'm not entirely sure, but so this might not be as new and exciting as I'm hoping it will be. But this study came out maybe a year or two ago. And I went and I looked at the details, and this was kind of interesting to me. There's just about no situation in which a college student hasn't texted on the toilet, in the shower, while having sex, you name it. Someone has sent a text while doing it. I find this hard to believe, but obviously this is what's going on today. So when you read a few more details about the study, they mention that they had a survey of 150 college students. And let's imagine that they're sampled randomly. We have a random selection of 150 college students. And approximately 84.5% of those students admitted to texting during a college course. And as you're reading that number, you might think about your own experiences. Do you think that's too low? Do you think that's too high? Do you think that sounds just about right? So this was, again, based on a sample of 150 students. Now, let's say you read a little bit more detail about this study, and you learn that the margin of error for this survey is 8%. What does that mean? So again, if you're thinking back to the slide that I just shared, where I said we used a sampling method that gives us a result this close to the truth 95% of the time. If we apply that to this example, what we're saying is we used a method in this survey that gives us a result that's 8%, or that's within 8% of the truth 95% of the time. So that might sound kind of odd, but we have this level of confidence. We're 95% confident that we obtained a sample result that is within about 8% plus or minus from the truth about the population. So again, you might want to write this down. We are 95% confident that we obtained a sample result that is within 8% from the truth about what's going on in the population. So if we took 84.7% plus or minus 8%, so what's that going to give us? So I'm not very good with math in my head. I should be, but I'm not. 76.7% to 92.7%, or 92.7, sorry. Okay, so I take 84.7%, I add and subtract the margin of error. That gives me this interval from 76.7% to 92.7%. So one way we can interpret this, based on what you've learned about in Chapter 3, is that we're 95% confident that in the population of all college students, the percentage who text during a college course is between 76.7% to 92.7%. So our original estimate, we're saying we have a certain level of confidence that it's within 8% of the truth of what's going on in the population. So this could be an interval that captures what's going on in the population, but it's possible that it's not going to capture that. We're not 100% confident that the interval will capture that. So I'm going to pause here, and I have one more quick video to wrap up a few other things.